Okay. Hi there. All right, today I'm going to show you guys about graphing systems of inequalities. And this is the second day of this. This is a bigger topic. It's not something I usually tackle in one day. So this is day two. I got the first problems already up here for you. It is y is greater than x minus 2. And x is greater than or equal to negative 1. So I'm going to graph these. And anywhere, and then I'm going to shade both of them, putting two of them on the same graph. A reminder that if I have just y is greater than or y is just less than, in fact, it doesn't matter where the y is in that, this will be a dashed line. And if it was the other way, if it has a line underneath it, x is greater than or equal to or less than or equal to, that would be a solid line. And so when I start out here, let me start out with the top equation. This will be the red one. That has a y-intercept of negative 2, which is there. And then it's got a slope. The slope is in front of the x. There's nothing there, so there's always an implied 1 there. So there's your slope of 1. So I'm going to go up 1, right 1, up 1, right 1. It's got positive slope, so it should go up and to the right. And once again, this is going to be a dashed line, not a solid one. So, make my dashed line going up here. Okay. Now, question is, I'm going to shade above the line or below the line? Well, since it's y is greater than or greater than or equal to, you shade above the line. If it was the other way, if it was y is less than or y is less than or equal to, you would shade below the line. And if it's, a steep line, you're looking at where it crosses the y-axis. So this is y is greater than, which means I'm going to shade above the line, because that's where the numbers that are greater than are on the y-axis. So that whole side of that line is shaded. The other one, x is greater than or equal to negative 1, well, that's just a vertical line, and I'm going to do this one in green. It goes through negative 1 on the x-axis, and it's straight up and down. That one's going to be a solid line. And then the numbers on the x-axis that are greater than negative 1 are on the right. You can always just pick one, say that point right there, which is 4. That's greater than 1, which means you're shading that entire side of the graph. Now I'm going to erase this part because what I'm actually looking for is where the overlap is. And remember, there's two ways to do this. You can either do it with the arrows or the overlap. I wouldn't recommend both. So this is where the overlapped area is, and that would be your solution area. Okay, so any point in that shaded area there will be an answer. All right, if you got questions on that, please bring them to class. Second one. This one, similar to the first one, the only difference is I don't have y alone. I got 2x plus y is greater than 2. I really like to have y alone in this, so I'm going to manipulate this equation. I'm going to get that y alone. What's in the way of having the y alone is that plus 2x. Opposite of adding 2x is subtracting 2x. So I've got y is greater than. You can write that either 2 minus 2x. I usually put the negative 2x first, because then the slope is first, the y-intercept is second, but I really don't care. You can have it the other way if you'd like also. As long as you know that when I write y is greater than 1 plus negative 2x, that 1 is still the y-intercept and negative 2 is still the slope, that's fine, okay? All right, so back to this. Blue one has a y-intercept of negative 3, 2, 3, slope of 2, that's up 2 over 1, up 2 over 1, positive slope. Once again, that'll be a dashed line. I'm going to shade below that line because it's y is less than. I'm going to put the arrows. I'm going to do the arrow technique this time, which I kind of like. Okay. And when I do the red line, y, or pink line, this one here, y is greater than negative 2x plus 1. 1 is the y-intercept, slope of negative 2, so that's 2 over 1, up 2, left 1, 2, left 1. Once again, another dashed line. Now this one is y is greater than, so I'm going to shade above the line. And the area that's going to be the solution will be where the arrows are pointing at each other. Here is the region that their arrows are pointing at each other, so anything in that shaded region there will be the answer. Okay. Got questions? Bring them to class. All right, this one, a little different. I like this problem. I took a picture of this one. You want to draw this one. I got two lines. I got a green line and I guess a black line, purple line. And you can see there's a shaded region. So what the question is asking for is write a system of equalities for the graph. So this time we're going to go the other direction. Instead of having the equations or the inequalities and graphing them, we got the graph, we've got to come up with the inequalities. So we're going to do one line at a time. I'm going to start with this green line here. You can see it's right here. All right, that's the green line. So I got to come up with the equation. I got y, I got an x. I need the y-intercept of that line. We'll start with that. Looks like the y-intercept is here, right? That's negative 2. And then I need to know what the slope of that line is. So I'm going to zoom in for a second here. We'll come back. If I take this and I do the rise over run, that's a rise of 1 and a run of 2, and that's in the positive direction, which means it's got a slope of 1/2. So that is what goes in front of the x. Move that y over a little bit. Okay, now it's a dashed line, so I know it's either going to be greater than or less than. And this is the solution area down here. So it's below the line, so it's going to be that one. The y is less than, since it's below the area that's shaded is below that line. So that's that equation that goes with that graph. Now I'm going to do the other line, and then I'll have my answer, which is the purple line here. So let me zoom in again here. Once again, same y-intercept, right? Still y-intercept of negative 2. Here's the y, here's the x. Negative 2 is the y-intercept. All right, now I got to figure out what the slope is. Still positive slope, right? And if I start here, let me erase that and I go, if I can go up to that point, between those two, that's up 2 over 2, which means my slope will be 2 over 2, which is really 1, right? So it's got a slope of 1. And let's see. This was a solid line, so it's going to have the or equal to under it. And we shaded above this line here in order to get that region shaded, which means it's going to be y is greater than or equal to. And there it is. That's the system of equations. Sometimes I might put a bracket around the side there like that so you know they go together, but that's the answer. Okay? All right, so that was number 3. Number 4, if I go down here, top one's nice and easy. The bottom one, however, doesn't have y alone once again. So I'd like to manipulate this equation to get y alone, right? And when I do that, I'm going to subtract x from both sides, and I get y is less than 2 minus x, or y is less than negative x plus 2. Those are the same things. All right, now I'm going to go graph those. Blue one, y-intercept of negative 1. And I've also got a slope of 1/3, so that's up 1 over 3. This would be going in the positive direction. This one's a solid line. The other one will be a dashed line because there's no or equal to underneath it. Y-intercept of positive 2, that's a 1, 2, y-axis, x-axis. And it's got a slope of negative 1, so that's up 1 over 1, up 1 over 1, all the way up. so if I draw my line through there, it should be like this. Oh, except it should be a dashed line. Okay, and let's see, my shading. All right, now let's do the shading. Purple line, this one here. Y is less than, that'll be shading below the line. The other one is X is greater, sorry, Y is greater than, which means the blue line I'm going to shade above it. Which means the solution area is where the arrows are pointing at each other, which is right in that region right there. Okay, and that's the solution. Last one. This will be a you try. Try this on your own. The one thing we'll do together, if you know, you try, go ahead. And hit pause and come back. All right, welcome back. So the bottom one, I need to get y alone, which means I'm going to divide everything by 3. All right, so I'm going to divide 3x by 3, 9 by 3, 3y by 3, and I get y is less than or equal to 3 divided by 3 is 1, 9 divided by 3 is 3, and there's my new inequality that I can graph. So let me start with the top one, the blue one. Y is less than 3x plus 4. 4 is my y-intercept, and it has a slope of 3, which is up 3 over 1, or down 3, left 1. That's a solid line. The other one, I'll do the shading after, is y is less than or equal to x minus 3, so that's at negative 3. Slope of positive 1. Whoops, I went the wrong way. That was negative. Positive 1. Okay, that's also got a solid line because it's got the or equal to underneath it. Okay, so let's see, which part am I going to shade? If I do the red line first, that's y is less than, so I'm going to shade below the line. And the blue one is also y is less than, so that's also below the line where you cross on the y-axis, which means the overlap area where the arrows are pointing at each other would be all of this over here. And that's the solution. All right. So that is what I got for you guys today. And I will exit out with a little bit more Dropkick Murphys. Have a great night.